students and faculty at Ohio State University. My name is Logan McKeun. I'm a sophomore agronomy major here at Northeast Community College in Norfolk, Nebraska. This is my friend.
Yep. Hey, I'm Rob Thomas. I'm also a student here at Northeast Community College. My major is agronomy and precision ag. And today what we're going to be talking about is the cover crop field here at R6. This field has been traditionally corn on forage sorghum. Soil type is a sandy loam soil, and it has been brought up by using cover crops from an organic matter of 0.75 over the past 3 years, about an organic matter of 1.1. So cover crops are helping build organic matter in the soil, and
well, I'd like to add to that, Rob, that this soil that we're working with here is definitely subpar as far as average soils for crop production in Nebraska, which is why it's really important that we go with this cover crop mixture and using these species to better build up this soil using biological controls. That's right. And doing it the most cost efficient and most natural ways possible. So now we'll go into kind of the species that we have planted here, if you'll just come in closer. So what we have in this field is we have three plots, I should say, excuse me. We have a rye only plot. We have a mixed species, which we'll get into what species we decided to go with here in a little bit. And then we have a no cover cropping system control. So what we have here is we have our brassica, which is forage collards, and then we have our oats, and then which actually this is a rye, and here we have oats.
Yep. And our winter pea right here.
And we went with this mixture because it gives a good difference in the soil biome, the root biome, and the subsoil, which is really important in a cover cropping system, is diversifying our root biome to get as much benefit from these cover crops as we possibly can. So going along with the diversity that we see in the root biome here, you can see here with a good mixture of cover crops here, we have a really nice, see some really nice diversity going on here in the root biome. So see here we have our rye, and look at how deep those roots are already getting with that plant. And the good thing about rye is that we'll see that the rye will actually dig deep down into the soil, deeper than a lot of other plants will do, and they will bring up old nutrients such as nitrogen and other leach nutrients down below the root biome and make them plant viable and are ready for the next species. The same thing goes for our brassicas here. They'll actually form a thick, deep root that will go deep into the soil and break up compaction, which this farm and a lot of our other Northeast farms actually have a problem with. And then our winter pea here, you can see we didn't quite get as thick of a stand here just for how it was mixed in the drill, but it's still going to be beneficial because it's going to bring up different roots or different nutrients and use different nutrients for different purposes that will help diversify the nutrient level that we see in our next year's crop. Another good thing about those is the nitrogen fixation that we'll see from there, and these legumes got inoculated too, so we should see some good nitrogen fixation. Then we have our oats here, and the thing about oats in Nebraska and planting them in the fall is that they will winter kill, but you can see already that this oat is really establishing itself already. So, and it's supposed to freeze this weekend, but you know what, with this kind of crop and how thick it is in the field, I think we'll be okay.
So what else we're going to talk about is the root zone and what our specific species are bringing up from the ground, from the soil. So if we look at each one of these species, they all have their own unique capabilities and what they can bring up from the root zone and what also they can bring in from the atmosphere. So if we look at specifically nitrogen we do not want to lose as nitrates. Nitrates leach down through the soil, and what the rye does, the rye has very deep growing roots that are going to grow down and extract and bring back up that nitrogen. Our forage peas, they're going to do a different thing with nitrogen. They're bringing in atmospheric nitrogen and changing it to ammonia. With that rhizobia bacteria, we inoculated these winter peas so they have a better capability to accomplish that. The brassicas are also going to help bring up deep nutrients because they develop a very deep growing root that can help bring up a lot of that nutrients. As far as potassium goes, the potassium nutrient, what it does, it attaches specifically to a soil particle. We end up with a lot of potassium in our water source due to water erosion from the field. So whenever that soil is loosely structured and we don't have a cover crop growing on our field, that potassium has the capability to leave our field with the surface runoff. Holding everything together with this soil, with the root structure, will help prevent that. Also, you can see we have a very sandy soil in our area on the farm here in Nebraska. So potassium is another nutrient that we're concerned about losing. With our low CEC soils, it has the capability to leach. So with all these benefits, we're going to be looking at keeping those nutrients from leaving our field and keeping them for the next crop. So after this year, after our cover crop grows over the winter, we're going to be planting corn back into this next year. So a lot of these nutrients that we have left over from the previous crop will be available to next year. A problem that can come from growing the cereal rye is our carbon to nitrogen ratio. So with our carbon to nitrogen ratio, we want to keep it, the rye, we want to harvest it at a lower stage. So we want to keep at the ratio about 17:1. If we let that rye grow, what it's going to do is the carbon to nitrogen ratio is going to increase. By the time it gets to a boot stage and it starts producing a seed head, we're looking at a carbon to nitrogen ratio closer to 37:1. So whenever we plant back into that, a lot of the nitrogen is going to be tied up due to all that carbon to nitrogen ratio and all that biomass that has been growing above ground. So what we want to do is make sure that we get that rye killed at an earlier stage. Whether on this field we're going to be using glyphosate to come in about 2 to 3 weeks before we actually plant our corn into it. One thing that we're going to have to do is we're probably going to have to add a 1034O to this field so that we don't end up with that very high carbon to nitrogen ratio penalty and we can get that corn crop established at a good time. So another benefit of planting a mixture of cover crops is we're trying to improve the soil structure. So with cover cropping and planting corn into this field, we're no-tilling. With no-tilling, we're not disturbing the soil profile. What we want to do is we want to keep this root structure intact because with our very sandy soil, it does not have very much of a structure. So we're trying to build that structure for it to better infiltrate a lot of the water and the rainfall, the irrigation water from the pivot. And we also want to build organic matter. So the more biomass that we get growing above ground will also equate to more roots growing below ground. Those roots growing below ground is going to build our organic matter in this soil, as we've seen this field being built up from about 0.75 to about 1.2.
So in our field here, the real cover crop champion we have is our cereal rye. And the big reason for that is weed suppression. So as you can see here, first of all, we're in the rye only portion of our field now, and look at the excellent stand that we got. In fact, this is actually my test plot here, and I had 25 plants per square foot, which equals well over 1 million plants per square acre. So what's the big deal with rye? Why is rye so beneficial? So what rye does that's really special is it produces an allelopathic chemical that will actually kill other plant species that grow near it. It's actually a root-produced herbicide that is natural to the environment, is completely biological, and does not require any human control to take care of these weeds. That's the real reason why, especially on a sandy farm like this, that we really do like our cereal rye. It has many benefits like we've discussed before, such as the increasing to organic matter, the bringing up roots or bringing up nutrients from below the root zone from other crop species such as our corn here, and a lot of other benefits such as carbon sequestration, which we'll talk about here in a little bit. But the real benefit we have from this rye is the allelopathic chemical that kills other grasses.
Another thing with the ryegrass producing that allelopath, when I saw scouting this field in the early spring, was there was almost no weeds in here for about the first month after they killed the rye. It was a real benefit because the delayed weed emergence allows the farmer better opportunity to get out there at the ideal time to control the weeds that do come up, whether it's broadleaf weeds or grass weeds. that are suppressed by that allelopath produced by the rye.
And one thing I did forget to mention earlier is that it's really important to terminate your rye at the right time for that exact reason, especially in the system here where we're doing corn on corn on corn, because that chemical will actually burn and can possibly kill that young corn plant when it's coming up. So it's really important to get in there and get it sprayed at the right time, make sure it's good and dead, and so you don't have any problems with your corn stand.
So Logan, tell us a little bit about how this cover crop is helping the environment.
Sure. So the first example that comes to mind is carbon sequestration. And so what that basically is, it's the plant taking in carbon dioxide and using it for photosynthesis. So when the plant takes in that CO2, it's keeping it in its biomass, it's storing it so it's not being released and can cause any damage to the environment, which is a big topic of concern. Today we talked about the species that we have planted here and their benefits of the soil, such as weed suppression, carbon sequestration, and the buildup of organic matter.
We've also talked a lot about the nutrient uptake by the cover crop that we have planted, keeping the soil structure in place and reducing a lot of the water erosion.
Well, that's all we have for you guys here from Northeast Community College. This is Logan McKeun.
This is Rob Thomas.
We're signing off, and go Big Red!